Welcome everybody to the webinar. My name is Alex Razumov. I'm a visualization coordinator with WestGrid and Compute Canada. And today I'll be talking about ParaView Web and three-dimensional visualization in a browser. In addition to ParaView Web, I will also cover several other techniques and tools for remote visualization and 3D presentation of models online. But all of these are related, so they all fall into the same category of visualization through a browser or remote visualization. So as Jana mentioned, the copy of the slides, you can find a copy of the slides at the link right there on the screen. We discovered that the screen doesn't refresh very quickly, so if you miss something in my presentation, you can always go back in the slides and review that material. So let's get started. ParaView Web is a JavaScript library API for writing rich web applications in HTML5 to do three-dimensional interactive visualization in a web browser. It's open source. It's a project from the commercial company Kitware Inc., but they made it open source, and actually pretty much all the projects are available as open source, and they support them commercially. So ParaView, as you probably know, is a widely used visualization package, multi-platform open source visualization package. And ParaView Web is, the idea of ParaView Web is that you can write your own web applications in JavaScript that will talk to a remote ParaView server running somewhere on a beefy machine, on a cluster, perhaps on a web server. And you'll be doing visualization interactively in the browser, but heavy lifting will be done by the remote service. So data processing and some rendering will be done by the remote system. Kitware wrote a handful of applications. The most complete of these is a visualizer. You can download all of these applications and run them on, well, either on your laptop or somewhere on a remote server. And all these applications are also open source. So in principle, you can write these applications yourself. The learning curve is quite steep, so I'm going to talk about this in a little bit more detail, probably in the middle of the talk. So if you know JavaScript, then you can start developing these applications yourself. Small three-dimensional geometry can be shipped by the ParaView Web server to the local client, and you can do some rendering, so small geometry rendering via WebGL. WebGL, as you probably know, is an implementation of OpenGL hardware GPU rendering library inside your web browser. And right now, WebGL is disabled in Visualizer, because they are moving now to a new backend. So the vtk.js rendering engine. vtk.js is another open source project from Kitware. There they do scientific visualization. vtk is a JavaScript library for doing scientific visualization using WebGL inside the web browser, but it's entirely client-based. So ParaView Web will be using vtk.js in a few months, but right now it's mostly disabled, at least in Visualizer and LightViz, the apps we're going to look at today. So when you download a binary version of ParaView for any platform, normally the core ParaView Web and the applications Visualizer and LightViz come bundled with the precompiled binary. If you compile ParaView yourself from source, then usually you have to download the apps from a separate repository, and then you have to include them into the compiled binary, so they have to be installed separately. When do you want to use ParaView Web? Well, if you want to do visualization in a browser, so for example, you might want to give somebody, your colleague, or maybe anybody in the world with a browser, access to your three-dimensional data sets, so they can actually go to a website that you provide, an IP address that you provide, and then load it, and they will see your three-dimensional models, data sets, and they will be able to play with it. They don't have to install anything, so that's a huge advantage of ParaView Web. They just go open the page in the browser and start exploring it. Perhaps you might want to have a simpler interface than what is provided by the default standalone desktop ParaView application. And in that case, you might want to implement this in ParaView Web. So LightViz, for example, is an example. I'm going to show it later on. Is an example of an app which with a much more simple or simplified interface that doesn't look as scary as the native ParaView desktop application. And perhaps you want to access ParaView from a mobile device like an Android or an iOS tablet, and you can actually run the ParaView Web server on a remote machine and then connect to it from a tablet. All you need is a browser, so it doesn't really matter where the browser is running. And it's actually very cool because you can walk around your office or go to a conference and show live visualization on a touch-friendly device, which is very convenient. On the other hand, you might not necessarily want to use ParaView Web if all you want to do is remote visualization. As I will show you today, when you run ParaView Web off a virtual machine in Compute Canada Cloud, it's actually quite slow, noticeably slower right now than running a native ParaView client server setup, simply because there are no GPUs. Mostly there are no GPUs on our virtual machines, and all rendering will be done on the CPU, and it's just going to be slower. So I'm going to show you in a few minutes. I'm going to show you a few demos even before I jump into ParaView Web. I will show you a few demos of running ParaView and also Visit, another open source visualization package in client-server mode of a virtual machine. So the service will be running on a virtual machine, and then the client will be, I'll be running it locally on my laptop. So I'll be showing lots of demos today, and almost all demos will be on a virtual machine. We have a fairly large system. I can't remember, 6,000 or 7,000 cores, something like that. A new system that went online last September at the University of Victoria is called Abutus. And you can, anybody with a Compute Canada account can apply for an account on the system. So we actually have two different systems. One is in Quebec, that's Compute Canada Cloud East, and one at Quebec, Compute Canada Cloud West. And you can apply for an account at either one. It's free. You don't have to be pre-approved. Essentially, anybody with a Compute Canada account can get an account there, and you can launch various types of VMs on these cloud systems. So we have three types of default VMs. There's a testing VM, which will give you you can have it for up to 1 month, and you can have up to 15 gigabytes of RAM, 2 virtual CPUs, and up to 40 gigabytes of disk space. If you need to do more computing, then you can launch a so-called compute instance that will give you more resources, but the maximum runtime is also limited to 1 month. If you're interested in running something like a web server or any other persistent server that is just listening for incoming requests and processes them, then you might want to launch a persistent instance. So the maximum duration is 1 year. And you can see the specs here. And if for some reasons these resources are not sufficient to you, then you can apply for additional cloud resources through our resource allocation competition that happens every year in the fall. So a couple of notes about running and launching VMs. If you don't use a VM, please don't let it sit idle because it'll be consuming resources. So if you finished using it, if you no longer need it, just make sure that you terminate it and perhaps even delete it, simply because it's going to be using resources and everybody else will be affected. And also on a VM, you are in charge of your own security, your own software installation, and even OS installation. So you'll probably choose, when you launch a VM, you'll choose a predefined operating system. We have about 15 or 20 different setups. So CentOS, Ubuntu, a few others. In most cases, it's Linux. And you'll install software. You'll be opening ports for incoming requests like HTTP requests, SSH requests, and so on. And you are in charge of your own security. So if bad things happen, well, bad things happen. So you'll have to perhaps delete a VM and then start over. We have a detailed guide on our wiki, which is referenced right here on the slide. So basically, what you have to do is, if you want to launch a VM, you'll need to first log into the cloud portal, then set up an SSH key pair that you have to use for the first login to a VM. Then you'll need to configure and launch a VM. So basically, you'll choose an operating system, you'll choose how much memory, how many CPUs you want, and things like this. Then you'll assign a public IP to that VM so that it can log in from the outside. Then you'll need to configure firewall to allow incoming SSH connections so that it can actually connect, and then you will launch it. So after that, you can log in into the VM and install software. If you want, so in the couple of demos I'm going to show you in the next few minutes, I'm going to run ParaView and Visit, and you have to install these yourself. We have details on all installation instructions on the website, referenced here. And basically, first, even before you install ParaView and Visit, you have to install a bunch of dependencies for these. So again, we have full documentation on the in our wiki. For most demos, I'll be showing the following mathematical function, which is called DecoCube. So you can actually Google it and see what it looks like, and you're going to see the picture in a minute or so. It's a mathematical function that is a function of x, y, and z in 3 dimensions. I discretize it at 30 cube resolution, so it doesn't take that long to load and visualize. So x, y, and z run from -1.2 to 1.2, and this is the entire Python code that I use to store that function as a VTK file. So you have an option when you write to VTK. VTK is a library for visualization of 3-dimensional graphics that's been around since the early 1990s. A really powerful library, actively developed, multi-platform, but it's a fairly big installation okay, I was just hearing echo. It's a fairly big installation if you need to write files to VTK. So an easier option will be to use a library called PyEVTK, which is actually very, very easy to install in Python 2, Python 3. And here's the entire code that uses PyEVTK to write the file called DecoCube. And as you can see, I simply go through, there are 3 nested loops in X, Y, and Z, and I write the file. First, before jumping into ParaView Web, I'm going to show you a ParaView standalone, well, it's not standalone, the native client ParaView demo, and then the Visit client server demo, and then we'll jump into ParaView Web. So for the demo, I'll be using, as I mentioned, a VM on the Abutus system at the University of Victoria. I already compiled ParaView on the VM, and it has to be compiled with OS Mesa support. So OS Mesa stands for Offscreen Mesa. Offscreen means software rendering, and Mesa is an open source implementation of the OpenGL graphics library. And you have to compile ParaView with OS Mesa support simply because in the vast majority of VMs, we don't have GPUs. That means you have to do rendering on a CPU. On the VM, you need to start ParaView server by hand using this command, and the --mesa swore AVX2 flag. Make sure that you enable OpenSWORE library, so that's the open source replacement for OpenGL, and that will make sure that you'll have fast rendering happening in software as opposed to GPU hardware rendering. Let me give you the demo. I will log in, so hopefully this is you now see a refreshed terminal window. I'll log in into the cloud system. So here I'm on the Ubuntu VM, and I will start the ParaView server. So I'll just say ParaView bin pv server --mesa -swr -avx2. So the server has been started. It's listening for incoming connections. That's the regular ParaView server. And then what I need to do, so it's listening on port 11111, and by default, the port is not open on the VM. So you have several options here. One option, we could open the port for incoming connections, but this is a security risk because anybody can essentially go, if they know the IP address, they can just go and connect via that port. And so anybody in the world can essentially connect without a login. Instead, I will do SSH port forwarding. So I'll connect the local port 11111 default ParaView port on my laptop to the same port number on the VM. And to do that, I'll use, again, on my laptop, I'll use the following command. So SSH to the Ubuntu box -L will connect the port 11111 on the local machine to the same port on the VM. Okay, now we are connected, and then I'll start the local ParaView client. So that's the desktop ParaView application. Let me maximize it. Okay, and then I'll click on the connect button. And here I already have a setup for Cloud West, but essentially all it does, it connects to localhost, local port 11111 on my laptop. Then I click on connect, and that will get us connected. So I can actually see that when I go back to the terminal where it says accepting connections, it said client connected. And then I can open the file system and I'll see the remote file system. So for this demo, I have data sitting inside /data ParaView Web data directory, and I'll load the file called decocube.vti. So that's the function I mentioned before. So I hit an apply button. The data set has been loaded. Rendering right now is happening. So data processing is happening on the remote server. The file is on the remote server on the VM, but rendering is happening. Well, actually, it's happening both on the VM and on my system, on my laptop. So there's a setting in ParaView where let me actually go into settings and render view. So you can configure the setting remote parallel rendering options. And right now it's set to 20 megabytes. And all geometries that are smaller than 20 megabytes roughly will be rendered on the local machine WebGL, and everything above that will be rendered on the remote machine. So if I set this to 0, then all rendering will be happening on the remote machine. It'll be very slow. So that's why you want to set this to some reasonable, not 0 number. And then small scale rendering will be happening on the in WebGL inside. Sorry, in OpenGL, not WebGL, in OpenGL on my laptop using the graphics card on my laptop. So let me switch to a different view. From outline, I'll go to surface view, and let's call that by, there's a single variable that is called scalar. And as you can see, it's a very nice rendering, very interactive, very smooth. So playback might be somewhat jaggy in the presentation software, but on my desktop it's really very smooth. All right, I'm going to call the contour or isosurface filter, and I'm going to draw an isosurface at the value of the function equal to 0.03. So here on the apply button, and this is the visualization we'll be doing throughout today's webinar. All right. So here we're doing visualization on using the client-server connection, ParaView client-server connection. I'm running the ParaView server on the remote VM, and I'm running a ParaView client on the local, on my laptop. And then most rendering is done by OpenGL on my laptop's graphics card. Really fast, really interactive, very smooth. Okay. I'm going to close ParaView now, and I'm going to show the same demo using Visit, which is another open source package, very popular package for scientific visualization. So here the setup is somewhat different. Let me start Visit on my laptop. Okay, here we go. And there's a setting here in Options, Host Profiles. It's actually the same page I just closed. So in Options, Host Profiles, you can set up a profile for a remote host. So I call it Cloud West. And basically, here I supply the nickname, the IP address of the remote machine. I say that, well, maximum number of processors. So this is a single CPU virtual machine. So we're just using one CPU. Path to visit installation of the system. And again, we have on the wiki that is linked from the slides, we have full documentation on how to configure and to install and configure visit on the remote VM. So username Ubuntu, and then I'll make sure that I tunnel all data transfer through all connections, well, the connection through SSH. All right. So I'll dismiss that. And all I have to do, I don't even have to start a visit service. So the visit client on my laptop will do that automatically. I'll open, go to File, Open Dataset, and where it says Host, Localhost, I simply navigate to Cloud West. And now I see the remote file system. So here I'll go to, let me see if this, no, I don't have a shortcut. I'll navigate to the same data directory. So it's going to be data, ParaView Web, data, and I'll load the same file, decocube.vti. Okay, the file has been read. We see that it's now an active source. I'll add a contour plot of the scalar variable, and then I want to have the same values. So I'll choose select by values, and then the same value, 0.03. Hit apply, and then I click on the draw button, and here I see exactly the same visualization. And again, it's happening. So the data file is sitting remotely on the cloud VM. I'm working in Visit. There is a Visit server running on the remote machine, and then there's Visit client that I'm used for both interaction on my laptop. Okay, so I'm just showing this to demonstrate you that you don't necessarily want to use ParaViewWeb if all you need to do is remote visualization. ParaViewWeb is nice because you can do everything through the web browser, but then you need to have an application. I'm going to show you several examples, and these applications are not as full-featured as the desktop apps. They have few options, and then in my case, they will the web application will work much slower because right now we don't have WebGL enabled in ParaView Web apps, well, in Visit and LightViz apps, and there's no GPU in the remote system. So the native client-server setup is faster than ParaView Web, right? I already mentioned that there's a handful of ParaView Web applications that's been written by the authors of ParaView Web. The most complete of them is called Visualizer. The idea of Visualizer, the goal of Visualizer is to provide the most complete interface that is as similar to the native ParaView app as possible, to the native ParaView desktop application. It also serves as an example of what end users can build with, can achieve with ParaView Web. It's an open source app, so everybody can just go browse its source. It's hosted on GitHub, and there is pretty good documentation at the Kitware GitHub side. Another one is LightViz. The idea of LightViz is to provide a much simpler interface where you have about, I don't know, 7, 8, or 9 predefined views, and there are not as many options in individual views. So basically select a view that you like, and then LightViz will give you a visualization, and you don't have an option to modify a lot of things. Arctic Viewer is a standalone JavaScript viewer for pre-generated images that were created in either Cinema or Catalyst. So I will not spend much time on this. We'll probably will do a webinar on both Cinema and Catalyst in the future. The idea of this, the idea of Cinema is that if you're doing rendering that is very heavy, that takes a lot of time, CPU time or GPU time to render, it will not be very interactive when you try to do it, when you try to load a data set, a large data set, and do it interactively inside ParaView, simply because it takes very long to generate each image. And the idea here is that you can actually pre-generate a large number of images that you can do in parallel. Let's say on a cluster, might take a few hours, might take many days. And then when you have a database of these images, you can load them into this Arctic View application, and then work with these images as if you were doing live visualization. So this is very nice if you have some huge data set and just don't want to, you want to have an interactive visualization, or an experience of interactive visualization without waiting for everything to refresh every time you update the visualization or rotate the image and so on. And Catalyst is an in-situ visualization library. So the idea here is that you can instrument your simulation code and output some data that is much smaller than the full data set, and this data is going to be used for visualization later on inside the Arctic Viewer. Data Viewer is a big data info visualization tool, so I haven't tried to play with it because it's currently in development. Hopefully, it'll be available soon. And there are a few other apps that I'm going to mention. So theoretically, as I mentioned, anybody can write their own ParaView Web applications, but you have to know JavaScript, so there's some learning curve. Okay, so the simplest way to test Visualizer app is simply we can do it on our laptop. As I mentioned before, when you download a precompiled ParaView application for your operating system, whether it's Windows, Mac, Linux, usually Visualizer is installed by default. So on my Mac, for example, all I have to do is start the following application. So I'll use PVPython, which is a Python, ParaView's Python wrapper, and then I'll call this ParaView -visualizer Python script, which is essentially it's a server application. It's a ParaView Web Visualizer server application that will start that application. Will also start the ParaView Web server, and then it will serve that application on port 8080, waiting for incoming HTTP requests. I also have to specify the content directory. So that content directory will be serving static HTML content, so things like HTML files, CSS files, and also the Visualizer JavaScript application is located in that directory. And then I need to specify the data directory that I want to be open to ParaView Web. So let me run this on my local machine. I have a function, an alias called start visualizer that will essentially run the stuff I just mentioned. And it started. And then all I do, I'll open a local web browser on port 8080, pointing to the local port 8080. And then hopefully it works. Yep, it works just fine. So let me drag this window a little bit out of the view. And here I have a very nice interface where on the left-hand side, I have the pipeline browser. Essentially, this is the pipeline, and there are a number of toolbar buttons here. The first one is the pipeline itself. The next one is a link to load files. So you can currently have two files in the data directory that are made available to ParaViewWeb, DecoQ and SAM envelope, another mathematical function. Then here you can add filters and predefined objects like a cone, a sphere, a wavelet, something else. Here's a link to save screenshots and state files. And here's a link to get more information about the data set. So let me go to the data directory and load the data file, DecoCube. Okay, it's been loaded. Let me move it a little bit here. You can actually hide the left pane entirely by clicking on the visualizer logger, and it's gone. So you can actually see visualization in full. Let me bring it back, clicking here on the visualizer logger. And then let me go to switch from the outline view to the surface view. Here we go. And then I'm going to color by the scalar variable, exactly the same stuff I've done in the standalone ParaView client, native client. Then let me bring up a contour filter. So I click on the plus button, and then contour is right here to build an isosurface. All right. And then, so here we have the pipeline. We have the original data set, and then we take the data set and we process it with a contour filter, so information flows from top to bottom, exactly the same GUI as in the native ParaView app. I'm going to hide the DecoCube and modify the value of the isosurface. So 0.03. This is the apply button right here. So I click on the apply button, and here we go. So I have a nice visualization. It's slower, as I mentioned, it's slower because right now WebGL in Visualizer is disabled, so there's no GPU acceleration on my laptop, and we don't have GPUs on the remote VMs. So everything is happening by software on a CPU. But it's still fairly responsive, not as fast as in the previous demo, but still fairly responsive. So there are quite a few options here. When you click on individual objects inside the pipeline browser, you'll see its properties here. So for example, the properties of the contour filter and representation and views. You can modify lots of things, for example, opacity. Let me change opacity right here. So go from a fully opaque to, let's say, semi-transparent. Here, click on the apply button, and then it becomes semi-transparent. As you can see, very, very similar to the native standalone ParaView desktop application, but you just have fewer options, fewer filters and fewer options in this dialog. Right? Let me close this. Actually, let me just terminate the local visualizer and go back to my slides. You can also run a visualizer if you install Visualizer as a separate application. So in that case, you will simply you can clone the GitHub repository and make sure that you run the Visualizer app in the Node.js runtime environment. And you can find instructions for this on the ParaView Web website. Running a single user visualizer in a cloud VM is essentially the same. All you have to do is, you have to compile the ParaView application, the ParaView server, the OS Mesa off-screen rendering version of ParaView. And you also need to install Visualizer because when you compile ParaView from source, Visualizer is not included. So you need to make sure that Visualizer goes into the right directory, and then you essentially do the same thing. You use the command. You use the ParaView Web Python server application. and specify which data directory you want to open, which port, and also specify the static HTML content directory, and then it should be served on a port that you specify. So the problem here is that it's not so interesting because only a single user will have access to your visualization. So for example, if you open this in your web browser, then you'll be able to do visualization, but anybody else can open the same web page, and then you will have a mirror setup where all controls and all views will be exactly the same between two users, between two browsers. So what you really want to do is have a multi-user visualization setup where you start a separate ParaView Web server for each user connecting to the front end. So normally this is done through a web server. For example, if you use the Apache web server, that will work as a front end, and then it will forward the request to the appropriate launcher. So there's quite a setup involved here. We'll be using, you can find full documentation on the website, on the ParaView Web website, which is linked right here. Very nice documentation for an Ubuntu box. So I spawned a Ubuntu VM in the Compute Canada cloud system, and you pretty much follow these directions. So the only caveat is that you have to set up the virtual host file and the launcher file, and this is somewhat tricky to do, so I have to pay attention to the details. And I provided the files, my setup files, in the same zip download that you had a link to on the title slide. So the zip file where you found the slides. There are also two subdirectories. One is called, I believe it's called ParaView Web, PVW, and there you can find these configuration files. So all you have to do is essentially, what I do, I put ParaView, install ParaView and Visualizer into the following directory, data/ParaView, and then the data files go into data pvw/data directory. I'll run ParaView Web server as a non-sudo user, and this is good for security reasons, so that nothing malicious happens. Then you give this user ownership of both the ParaView directory and the JD directory. You set up the Apache virtual host and a few other things. And then if things don't go wrong, don't go right, you can always check the following directory for any errors. And it's actually very handy if things don't work for you. Then you can see what the exact error message was. So let me start this in multi-user setup, and then all of you can connect to the VM, and you can actually do your own visualizations using the same setup on my virtual machine. So what I'm going to do, well, the commands to do that. So I wrote a couple of bash functions, which are very handy if you don't remember or don't want to type these commands. You simply say start ParaView Web Server, stop ParaView Web Server, and these commands essentially start the. So the first command starts the Apache server, and then runs the launcher as the ParaView Web user server, pointing to well. So inside the launcher setup, I point to the right data directory, right HTML directory, and so on. So you can actually, offline, you can take a look at this file and see how this happens. Okay, so let me start the machinery. I'm going to log into the virtual machine, and I'm going to say start ParaView Web, and it's been started. So now all of you can go to this web page and run demo on your own machine, on your own laptop. So you will see exactly the same GUI you saw before, and feel free to load a file. So I click on load file and just pick up one of these files. The silo file will not load because I think, if I remember correctly, I did not compile ParaView server with the silo file support. But you can load one of the VTI files, for example, DecoCube VTI. Here we go. And let's go to a different view, for example, wireframe view. Let's call it by the variable. And then each one of you will see your own visualization. And I can actually check how many people connected to the system. So if I count how many ParaView Web processes I have, so there are a couple. So somebody else is running this visualization as well. All right. Let's try doing something a little bit more complex. Let me again apply the contour filter, and then let's draw it at the same value, 0.03. Hit the apply button. Then let's add a clip filter. So here I clipped the data set. One part, everything on one side of the clip plane is thrown away. Everything on the other side of the clip plane is shown. And as you can see, now we have three objects. So the original data set goes into the contour filter, and then it goes into the clip filter. And then you can actually make these visible or invisible by clicking these icons, these round circles. So right now, for example, only the contour filter is visible. Right? And then when you click on an individual object, you will see its properties right here in the lower left corner. Okay. So let's see. Saving state, this is fairly important. How do you save? So first of all, you can save the visualization itself. So if you go to, if you click on this button right here, screenshot, lets you, you can upload a PNG file, specify the resolution you want to save it, and we'll upload to the server. And then you can also upload the state file, and this is actually very useful if you want to recreate this visualization later on your own desktop. So you can save this file. It'll be uploaded. So when you click the upload button, it will upload it to the server, and then you can simply download this file. So it's a standard ParaView state file to your system. So using a regular CQ copy command or CQ FTP command, and then you can simply load it into your local ParaView client desktop application, point to the right location of the data file, and then click apply, click load or apply, and it will automatically recreate visualization on your local system, which is nice. So that is, of course, if you have the data file downloaded as well to your local system. So let's see, we don't have a lot of time, so I'm going to show you one more demo. And if you're curious, you can just try loading other data sets. So let me try to do edit the transfer function of a wavelet in the volumetric rendering of a wavelet. So I'm going to go back to the pipeline browser, clicking on this button, and I'm going to erase everything I have here. So alternatively, I can simply reload the website, and every time I reload it, it will open a new ParaView. It will start a new ParaView web server, and will open a new visualization instance for me. So let me open let me click on the plus button. I'm not opening a dataset. I'm opening a predefined object, so I'm opening a wavelet object. Here we go. Let me just drag it right here, and then I can spin it. So this is the outline view. Let me zoom in a little bit, and let me switch to a volumetric view. This is a wavelet function, so color by the value of the function. And this will probably take a little bit, it takes about a second or two to refresh because it's volumetric rendering, and we're doing that on a CPU. So this is a standard volumetric rendering you'll encounter in ParaView and also in Visit. To edit the transfer function, which maps the value of a function to the actual signal strength and to opacity, what you do is you click on this gear icon next to the color bar, and then click on this icon. That lets you edit the color map. If you double click here anywhere, that will introduce a new point that you can drag around. And let me just change the transfer function so that I only have some non-zero signal for the high value of the data set, or high value of the function. So here we go, something like this. And then you can modify switch to different predefined color map, and you can set up the range and so on. So the usual controls you see in the desktop ParaView app. Okay. You can also run animations inside ParaView Web. If you load a data set that has a time component to it, then the playback buttons will appear at the top, and you can simply play back, go to the next frame, to the previous frame, and then you can save the image, the movie, visualization movie. All right. The second application I'm going to mention briefly because we don't have a lot of time is LightViz. The idea of LightViz is to give a much simpler interface to each visualization. So we have about 8 or 9 preset visualizations, so things like clip, contour, slice, multi-slice, streamline, volume, threshold. And so here you simply load the data set. And one thing that is unique to LightViz is you have to format the data set in a particular way. And that is done, you can go to documentation and see how it's done exactly. And then once you load the app inside your web browser, it will give you a selection of data sets that are available. So you click on the data set you want, and then it'll open a view similar to this one, where on the left you see predefined views, and then you click on a view that you want to show, and then you can play with the view in the main visualization window, but you won't have as many options as in Visualizer. All right. So writing ParaView web applications is somewhat difficult because there is a steep learning curve. I was actually hoping when I was preparing for this webinar, I was hoping that I will go through some examples of how to write your own apps, but this is certainly way beyond the time limit of this webinar. So all I'm going to say is there is pretty good documentation. There are lots of code examples on the following websites, so on the GitHub page. And they're pretty good. There are some live examples that you can just see the code and see what it does inside the web browser. So try going to these. Play with the Visualizer and LightViz source as well. And if you have an application, a specific visualization that you want to do in the web browser, and if for some reason Visualizer app is not sufficient for you, then please let me know. I'll be happy to look into this in more detail. And also you can talk directly to Kitware. So they are the authors of ParaView and ParaView Web, and they'll be more than happy to help you write an app in ParaView Web app to do exactly what you want. But of course they will charge for support, so because they're a commercial company. So if you talk to Kitware, please also keep me in the loop. I'll be very interested to know what people are doing. Okay. All right, so this takes us to the last part of the webinar. What if you want to simply share a three-dimensional object? So for example, a three-dimensional scene or three-dimensional model online in a web browser, but you don't necessarily want to use Visualizer for it or to write your own ParaView Web application. There are actually quite a few options for this. So why would you want to do this? Well, for example, if you work in archaeology or some other humanities field, social science, you have a three-dimensional historical artifact, or you have a map of a building, or some three-dimensional terrain maps from LiDAR point cloud maps and so on, and you want to share these online. So this is not exactly scientific visualization. This is simply you have a three-dimensional model or prototype, and you want to people to go to a web page and then spin it around, perhaps zoom in, zoom out, and click on some predefined parts of that object to give them more detail and so on. So there are quite a few options. And so to see what I mean by this, if you click on this web page, that will open the Smithsonian X3D Visualizer. They put quite a lot of their objects there, objects from the collection online. So here you see what I mean. So you can spin an object, you can zoom in and zoom out. You can click on predefined hot maps, although I don't think this image has any hot maps, and so on. So this is useful for many different fields, and you can even do scientific visualization using this. So one of the examples I'm going to show you is scientific visualization that is shared in exactly this way. So ParaView Web can do all of this, but it's probably too much because ParaView Web is a little bit complex, and you don't have to go to all the details of writing an app and setting up ParaView Web Server and so on. So the simplest option is to simply export your file as WebGL. If you go to ParaView, this will let you export a scene as a WebGL file, and then you can load this file into a web browser, and then it will let you spin it around. So I'm going to run a demo right now very quickly. Again, on the Cloud VM, if I type, let me SSH back into the VM. I'll say start. Shall let me stop the ParaView Web, and then I'll start WebGL demo. Okay, so it's serving the file on the default HTTP port 80. And the way I do this, I simply run a sudo python command in the directory that hosts the WebGL file, and I'm asking to serve the file on the port 80, which is the default HTTP port, which is open on the VM by default. And if you point your browser to the following web page, you will see this live demo. So here I have exactly the same object created in ParaView, exported as a WebGL file, and then it's rendered. The problem here that is all it can do here is essentially spin it. Right, you cannot zoom in, zoom out, and do other things. You cannot really do color here, and there are a few other limitations. So one of the things is also you'll notice immediately is that this is running using WebGL inside your. There's no server here. It's running WebGL using WebGL inside your web browser, and it's probably taxing fairly heavily. So on my laptop, for example, I see near something like 70 or 80% CPU usage, and I can already hear fans spinning. So this is not really a good approach. Let me quit that. Oops. Yeah, I just stopped it. So a better approach would be to use a vtk.js library that I mentioned already in one of the first slides. That is library developed by Keith Ware, the authors of ParaView and ParaView Web. And it's a JavaScript library for doing rendering, geometry rendering inside WebGL in your web browser. So it adds some things, some nice things. You can add color, you can zoom, you can add a lot of different things. And basically, it's a merge. Well, it leverages this library leverages a lot of VTK existing functions in the classes, and it simply gives you a lot of VTK functionality inside JavaScript. And you can see they have a very nice example of a scene viewer that loads a local file and then renders it via vtk.js or via WebGL. If you go to the following web page, it asks you to load a file, so choose file, and here you have to supply a vtk.js file that you can actually create with ParaView. So on the same page, they have a link to a code right here. It's a Python code, ParaView Python code that you can run in Python to export the vtk.js file. And then, so let me just do the. I already have the file somewhere inside. Right here, datacube.vti.vtk.js, right here. And I simply load it, and then it gives me, the same view, but I can also zoom in and zoom. There's not much else I can do, but still nice, much nicer than the previous demo. And it's running, there's no server involved. It's running completely on the client side inside your web browser using WebGL hardware acceleration. Right? They have some very nice examples. So I'm going to click on this one. And as you can see, you can actually have fairly complex scenes visualized using vtk.js and WebGL. And it's very responsive, and it's not as taxing as WebGL, well, just pure WebGL. So let me try this one, the very last one. The very last example is actually very interesting because it's scientific visualization, and as you can see, so it's a scene that was rendered most likely in ParaView. I don't exactly know what it is, but it certainly looks like a scientific visualization, and you have a number of surfaces, polygonal surfaces here rendered in color, and you can actually zoom in and zoom in. So there's no reason why you cannot use this for sharing scientific visualization models with your colleagues online, right? And again, there is no server required. All you have to do is serve a static HTML page, and all visualization will be done on the client side. Right. So finally, there is the package that was written by the Visual Computing Lab at the Institute of Science Technology, Information Technology in Italy, in Pizza, Italy. And it's 3D Hop, and it's actually used widely in humanities. And so I have a few slides that show how to set this up. So the idea is that you can export a file. So you can export a polygonal mesh file, basically a scene file from ParaView, and you have to store it as an X3D file, and then use MeshLab software. It's a separate piece of software to convert it into PLI. So the problem with PLI is that you can also export PLI from ParaView natively, but it will not give you nice colors. So there are a few things that will be missing. So I recommend to have very nice visualizations. I recommend to go through this route, using exporting as X3D, and then using MeshLab to export it as PLI files. And then essentially you do you modify, you download 3D Hop to your server, and then you'll modify the index .html file to point to the correct location of the model and what you exactly want to do, and then you simply serve the static HTML file on a HTTP port, open it to the world. So let me give you an example. I'll start. Let's see where it is. 3D Hop right here. And now, if you go to the following web page, right here, point to web browser at this web page, you will see the demo, which has been created with ParaView, standalone ParaView, and then exported as a PLY file, and then import it into 3D Hop. And here the interesting thing is that you can actually, so you can zoom in and zoom, you can spin around, but you can actually create a hotspot. So I'm going to show you the very last demo, this slide that tells you how to do this exactly. And so inside the zip download that all of you have, there is a subdirectory called 3D Hop, and there I have the example HTML file. So both the index.html and the hotspots.html file. So now if I go to the following directory, to the following URL, so let reference at on this line, this will give me, let's see, it's slow probably because a lot of people are now trying to run it on their system. Okay, interesting. So it is quite slow because a lot of people are trying to hit the server right now. So what will happen here is that you will see in the demo, maybe some of you see this already, you will see another button, the one next to, I think somewhere around here near the bottom. And when you click on it, it will highlight two predefined hotspots. When you click on one spot, it will create a pop-up window. When you click on the second hotspot, it will take you to the WestGrid homepage. Okay. I'm going to go to the very last slide because we are running out of time, and I want to leave time for questions. I showed you several technologies today. It was meant to be a webinar on ParaView Web, but I think it's very important to see all the options and to see where you want to use ParaView Web versus the client-server setup. As I mentioned, right now, client-server setup is faster because, first of all, right now there's in Visualizer app, there is no WebGL. And so it'll be enabled probably 5-6 months from now. And also, there are no GPUs on the Cloud VM. So if you're running this off a ParaView Web server that runs on a machine that has a GPU, then things will be faster for you. But unfortunately, on the VM, the vast majority of Cloud VMs don't have GPUs. But still, it really depends on what you want to do. Of course, you can run these. So in principle, you can run the web server and the ParaView Web server on different machines. You can run the ParaView Web server on a cluster, even in parallel. So the setup will be a little bit more complicated, but then rendering will be happening faster. Or perhaps you just want to apply for a VM that has not a single core, but perhaps 4 cores or 8 cores, and then visualization will be happening faster for you. So I showed also ways of putting 3-dimensional models online, so 3D Hop and WebGL and vtk.js, and so the tool you want to use is really up to you. All right, so thank you everybody for attending. I hope this was useful, and our next webinar, visualization webinar, is going to be in May, and we're going to announce the topic shortly.